Hello, my name is Joe Mannis and I am the president of the French Cable Station Museum. Today I am honored to present a short presentation of the French Cable Station Museum. For those of you who are not familiar with the museum, here is a photo. We are located on Route 28 and Cove Road near the Orleans Yacht Club. Today, I will discuss the history of the transatlantic telegraph and the museum. Then we will have a brief tour of the museum. This will be followed by some typical questions that have been asked and the answer to these questions. Here we go. Welcome to the French Cable Station Museum. This station, when it was in operation, was the American termination point for a telegraph cable that came directly from France to Orleans. It was called Le Direct, the direct cable. We will have a brief presentation of the history of the transatlantic telegraph and the French cable station. This will be followed by a tour of the facility and an opportunity to see the equipment used. You are in the superintendent's office. This office is essentially as it was through the years. Look around you and you will see the walls are covered with a few photos and news clippings. Some of these were given to the museum by the Smithsonian Institute. This French cable station was in operation until 1959. As you walk around later, you will see the actual equipment that was in use at the time. A large portion of the equipment can still be demonstrated. There is an interesting story associated with this station. In World War I, the American general in France, General Pershing, communicated with the United States government through this station. In 1918, a German submarine sank 4 barges off the coast of Orleans. It is believed by many that the attack by the German submarine was an unsuccessful attempt to disrupt the communication between Pershing and the U.S. government. In 1927, the news that Lindbergh had landed in Paris came through the station and was distributed from here throughout the United States. When the station closed in 1959, a group of Orleans citizens raised money and attempted to purchase the station from the French government to preserve it. Charles de Gaulle was in power at the time and refused to sell. De Gaulle left power in 1969, and in 1972 the citizens were able to purchase the station and set it up as a museum. The station is listed in the National Register of Historical Places and other historical commissions. The Smithsonian worked closely with the museum to set up the equipment and still maintains interest in its activities. Field Curry, a consulting engineer for the Smithsonian Institute, volunteered his time to set up the equipment when the station was purchased. In recent history, a float entered by the museum won first prize in a 2002 July 4th parade in Orleans. The float depicted the station in operation and had some of the furniture and equipment on the float. Now let us examine the history of the transatlantic cable. The first transatlantic cable was actually English, not French. Why was there a need for this cable? What was happening in the world that made rapid and reliable transatlantic communication so vital? What were the challenges facing the people involved in trying to lay a cable for over 2,000 miles on the bottom of the ocean? How was the operation financed? When was it finally a successful project? We will follow the progress and success of the transatlantic cables that finally resulted in Le Direct. The first telegraph line in the United States was in 1844 from Baltimore to Washington, D.C. The telegraph technology was well received in the U.S. and Europe. Within 10 years, there were more than 23,000 miles of telegraph cable in the United States. Europe was covered with over 20,000 miles. The British had installed over 4,000 miles of telegraph cable in India. Plans were made to link Asia and Europe together by stringing a telegraph through the Ottoman Empire. The entire world was being linked politically and financially with the rapid communication of the telegraph. The world was being connected, but even though both Europe and the United States were each covered with a network of telegraph, they were isolated from each other. They were separated by over 2,000 miles of water, the Atlantic Ocean. It was a 1-month round trip at best. 1 out of 6 ships had to turn back, were sunk, or got pushed off course by storms. Doing business was very difficult at a time when the United States was looking for European investment to help fuel its growth and expansion. The United States was being left out of the world community. A few far-sighted men saw the need for a connecting telegraph cable. Some people had believed a land cable through North America and Asia to Europe would be the best choice. This would have been over 10,000 miles long through some of the most barren and difficult territory. Others believed the 2,000 miles across the Atlantic would be the best. The U.S. Navy had recently conducted soundings to determine the terrain beneath the ocean and found a route that was fairly flat. The first cable to Europe would be a transatlantic cable from Great Britain to Newfoundland. One major challenge was how to finance the project. This was not a government project such as we had to travel to the moon. This was to be a private company established to make money. The United States and British governments gave some assistance by providing the ships to lay the cable and by guaranteeing a small amount of revenue from government communication. The financing was done by Cyrus Field, an American millionaire. He raised the capital amongst his wealthy American and British friends. In 1854, Cyrus Field had been approached to help fund a project to run a telegraph line across Newfoundland and then connect via short submarine cable to the landlines to New York. This would cut 2 days each way off for a total of 4 days from the round trip to England. Cyrus Field looked at his globe and had the idea of continuing the cable from Newfoundland to Ireland. The construction of a cable for under the sea was one of several technical challenges. On land, the cable is bare and isolated from Earth by insulators. No insulation is required to the atmosphere as air is a great insulator. Salt water is a great conductor, however, so the cable had to be insulated from the water. In addition, it had to have the strength and integrity to lie on the uneven ocean floor. The cable developed looks similar to the one shown in the drawing. The center is solid copper, surrounded by copper strands, provided the conductivity for the electricity, and using copper and strands makes it flexible. The insulation was a natural substance called gutta percha. It is extracted from a tree found in Malaysia, similar to the way rubber is extracted from trees. It is an excellent insulator and does not deteriorate in salt water or under high pressure. The outside of the cable is made up of strands of galvanized steel to give it strength and protection from the elements. The jute yarn provided a cushion for the galvanized steel. An interesting side note, gutta percha is still used as padding inside fillings or inside the root canal during root canal therapy. The 2,600 miles of cable weighed 3,500 tons. and was much too heavy for one ship to carry. Two ships, each carrying half the cable, was to be used to lay the cable. They would both start in Ireland, and when one ship was empty, the cable would be spliced, and a second ship would continue on to Newfoundland. The U.S. Navy provided the USS Niagara along with its support ships, and the British Navy provided the HMS Agamemnon along with her support ships. The crews were all Navy personnel, supported by civilians for the actual laying of the cable. 60 volts was put into the cable at the transmitting end. After traveling over 2,000 miles in length, the result is a signal of only a few milliamps at the receiving end. It was not practical to use short and long signals for dots and dashes as was used on land, as the dashes and dots would tend to join over the 2,000 miles. Marine telegraph transmission used positive voltage for a dot and negative voltage for a dash. This made for a more positive distinction between dots and dashes. The signal received was too weak to activate any electromechanical device such as a printer or sounder. In 1820, several scientists discovered that a small current passing through a coil of wire created a magnetic field. A magnet placed in the coil would line up with the magnetic field, much like a magnetic needle in a compass would line up with the North Pole magnetic field. If the current is reversed, the magnetic field is also reversed. The magnet then rotates in the opposite direction. In 1858, Lord Kelvin of England invented the mirror galvanometer. By placing a mirror on the magnet, a very slight rotation of the mirror made a reflected light move along a display where it could be seen by the human eye. One direction for a dot and the reverse direction for a dash. They had to develop a method to lay cable on the bottom of an ocean that was 2 or 3 miles deep. The English Channel was less than 200 feet deep, so laying cable this deep was a new problem. 3 miles of cable weighed almost 5 tons. It had to be let out at the correct speed to prevent breaking the cable. They learned by doing or on-the-job training. On the first try, the cable was laid only 5 miles before it broke. The next attempt went almost 300 miles. This was much better. They were learning fast, but had to delay for the winter. The fierce North Atlantic storms made work impossible. In 1858, they had success using a different procedure. The two ships started from the middle of the ocean, connected the two cables, and sailed east and west toward Newfoundland and Ireland. The second attempt that year was successful. Queen Victoria sent President Buchanan a congratulatory message. He returned her message within 3 hours. This was a great step forward from 4 to 6 weeks by ship. The cable was too thin, making the signal very weak. When they attempted to increase the signal using a higher voltage, the cable was burnt out. It had lasted about 6 weeks with about 400 messages being transmitted. A new cable project was delayed, however, because of the American Civil War. When President Lincoln was shot in 1865, it was 10 days before they heard the news in London. The following year, it would have been minutes. In 1865, they were ready to go again. The delay was fortunate in one way. A ship became available that could carry the entire length of cable. The SS Great Eastern had been built in England as a passenger ship. It could hold 4,000 passengers and enough coal to sail around the world. It was over 2 football fields in length, with paddle wheels as high as a 5-story building. It was not successful as a passenger ship. There was not enough demand to make it profitable. It was purchased for a fraction of its cost and modified to lay cable. In 1865, using the SS Great Eastern, a cable was laid starting from Ireland. At 600 miles from Newfoundland, the cable broke. They knew the location of the cable, but they were not able to retrieve the cable. They did not have the equipment on board to lift such a heavy load. The next year, a cable was successfully laid from Ireland to Newfoundland. They were able to retrieve the cable from the previous year, splice the cable, and continue the line to Newfoundland. There were now 2 cables. The London and New York financial markets were tied together. The cost of transmitting a message was quite high, so the main users were government and big business. A few years later, a famous author wrote in a popular London play, "How much does it cost to send a telegraph to New Jersey?" The answer was, not nearly as much as it's worth. The Associated Press and other news services got a big boost. One message could be sent across the telegraph line and then distributed to all subscribing newspapers. There were 2 major events in U.S. history that improved communication and travel. The transatlantic telegraph changed communication to Europe from weeks to minutes. The Transcontinental Railroad changed travel to California from months to days. The French were not happy with the situation, however. All their communication had to go through England. The French wanted secure government and business communication. They were competing with England over colonies and trade in the Americas, as well as the whole world. France owned a group of islands off of Newfoundland called St. Pierre. They would use these islands to route a cable from Brest, France to St. Pierre and on to the United States. In 1869, the French laid a cable from Brest, France to St. Pierre to Duxbury, Massachusetts. The Great Eastern was used again to lay this cable. Duxbury was a busy shipping area, and the cable was subject to frequent damage from ships. In 1879, another cable was laid, but this time it went into North Eastham, Massachusetts. A new ship, the Faraday, had been designed and built primarily to lay cable and was used to lay this cable. Here is a postcard from the Times showing a cable station in North Eastham with the Three Sisters lighthouses on the right. It was quite an impressive building. North Eastham was an isolated place, and the operators and their families were not very pleased to be there. There was no community around, and it was 2 miles to the main road. Reaching the station in bad weather was difficult. In 1891, a new station was built in Orleans, and the cable was extended from North Eastham to Orleans. The extension cable ran over land and through the Nauset Marsh. The sea cable from St. Pierre was connected to the land cable inside this cable shack. This connection was in operation from 1891 to 1932. The shack can still be found at Nauset Light. In 1898, L'Eau Direct was laid from Brest, France to this Orleans station. The cable was almost 3,200 miles long. This was the cable used until the station closed in 1959. The station was closed temporarily during World War II when the Germans occupied France. The English actually disrupted the cable to prevent Germans from communicating to what was then neutral United States. The United States government moved all the equipment to a secure location when the United States entered the war. It was not until 1952 that the station was in operation again. It could not compete with the newer technology and closed permanently in 1959. History of both land and marine telegraphy would not be complete without an interesting story about Morse code. Look at Morse code. The letters that are used the most in the English language have the least number of characters, 1 or 2. The letters used the least have the most characters, 4. Morse determined the frequency of use of the letters by going to a printer using individual typeset letters. The letters with the largest box, or most boxes, were used the most. In addition, a printer stored the capital letters in a case on the upper shelf, and the small letters were stored in a case on the lower shelf. The letters became known as uppercase and lowercase letters. In another section of this DVD, you'll see the station as it is today. At one time, there were several thousand marine telegraph stations in the world, all of them on prime seashore real estate. Today, there are only 3 that remain as a museum. There is a French cable station in Orleans, the Porthcurno Telegraph Museum in Porthcurno, UK, and the Heart's Content Cable Station in Heart's Content, Newfoundland. This concludes the history portion of this DVD. Now I would like to take you on a tour of the museum. This brief tour is not a substitute for visiting the museum, but it will give you a sample of what the museum has to offer. The museum is located in the original 1891 building which housed the station. The tour starts in the superintendent's office with a short video of the history of the transatlantic cable and the museum. Then we will proceed through the rest of the museum. The original equipment is still in place, and some of it can be demonstrated. We have seen the history video, so we will start in the superintendent's office with the tour. The walls are covered with many photos, some of which came from the Smithsonian in Washington, D.C. Note the old roll-top desk with the rotary phone. The phone fascinates anyone below 13 years of age. After they dial their home phone number, they are exhausted. Next to the desk is a press used to copy documents. The documents with the wet ink is put into the press along with a thin piece of paper called onion skin paper. The wet ink is transferred to the very thin paper. It is in reverse, but it can be read through the thin paper from the back. There is a photo of the cable shack at Nauset Light. The shack connected the land cable to the sea cable and provided a means to test the cables. At one time, it was owned by a lady who added several rooms. The seashore now owns the shack. Also in the room is a one-of-a-kind statue given to the cable company general manager when he retired. You will be impressed by the artwork in the statue. A cable is shown across the globe. On display also is the flag of St. Pierre, telling the story of where the French settlers came from. They came by ship from Basque, Brittany, and Normandy in France. The French operators for the station came from St. Pierre. Many families stayed in Orleans after the station closed. A plaque in the room shows the name of the original founders of the museum. Let's look around the office. We will leave the superintendent's office and go down the long hall. As you walk down the hall, you can see many interesting things on the wall. There's a photo of Cyrus Field and his rich associates. Also, a piece of his original cable that was donated to the museum. There are also several newspaper articles of the museum on display. On the wall are several maps showing the cables in use today. 98% of the world's communication is through fiber optic cable today. It is fast, not affected by weather or sunspots, and the cable is very secure. It is hard to tap into a cable and steal the message. At the end of the hall is a large display case. In the case is a copy of the Congressional Medal given to Cyrus after he laid the first cable. Next to it is a sample of the original cable. Cyrus had a lot of the cable left that could not be used, so he sold it as a souvenir. He knew how to make money. In the case are also many samples of equipment and cable. Also, there are some of the souvenirs they sold to pay off the original mortgage when the station was purchased from France. Now we will go into the repair room. The repair room was where the men had their tools and equipment used to repair the cable and other equipment. On the wall are photos of the men out at sea repairing the cable. There are many samples of the cable, both that are used in the deep ocean and those that were used near the shore. To repair the cable, the men went out in a salt hay barge if the break was close to shore. The barge can be seen at the Salt Pond Visitor Center. Breaks farther out required a larger boat. In the room is a collection of glassware made by the Sandwich Glass Company of Cape Cod. The pattern is called the cable. Before Cyrus laid the cable, the same pattern was called the rope. Let's take a look at the repair room. You were probably wondering, how did they know where the break in the cable was? We'll go into the test room. The test room contains the equipment to determine the location of a fault in the cable. The equipment was used to find the location if the problem was a short to the seawater. This can be demonstrated. In the room is a Hertley magnifier, one of the 3 remaining in the world. It amplified the weak signal from the marine cable to a signal 18 times as large. The amplification was done in a very simple way without the use of vacuum tubes or transistors. The method used the Wheatstone bridge. There are only 3 on display in the world. You may want to see this one and learn how it works. It was very sensitive to vibration and was isolated from the surrounding area. The technique for isolation includes the use of tennis balls. Let's take a look at the test room. We will now go into the operations room. The operations room was the heart of the station. This is where the signals came in and were retransmitted. The marine galvanometer is located here. The operator would sit and watch this for hours to read the message coming in from France. Another operator would write the message down, and a third operator transmitted the message to New York or Washington, D.C. Let's see how it looked. In later years, the siphon recorder was used to record the incoming signal. This was done with a very thin glass tube that drew the ink to the paper. To make the tube last longer, it was vibrated, so the trace is a series of dots. They were paying for the land telegraph line to New York or Washington by the minute. To speed up the rate of transmission, they created a paper tape for transmission of the message. The mallet perforator allowed an operator to prepare a tape for transmission. Individual strokes created dots, dashes, and spaces for each letter. It took time, but saved money. Later in time, a device called the Kleinschmidt perforator, similar to a typewriter, created the same type of tape, but with a single stroke of a key for each letter. The paper tape could then be read into the automatic transmitter. The use of this automation reduced error and increased the transmission rate. This room also contains the artificial cable used in duplex operation. The artificial cable did not go anywhere, but existed only in the cabinets. Each artificial cable box looked exactly like 250 miles of cable. The artificial cable and the real cable were placed in a Wheatstone bridge formation. Now a signal could be sent in both directions on a single wire in the real cable. It doubled the capacity of the transatlantic cable. Let's take another look at the operations room. Hold it! Don't run for the exit. There's not actually a quiz at the end of the tour. There is, however, a board with questions and answers. The user puts a wire on the question, and when the correct answer is touched with the second wire, the lamp is lit. This item is very popular amongst students. The tour is free, but we would appreciate any donation. Also, please sign our guest book. We generally have visitors from a dozen countries all over the world and about 2/3 of the states in the United States. Now that you have a flavor of the museum, come and visit us. Our guides love to show visitors around. Thank you. I've given these presentations about 18 times in Cape Cod at libraries, organizational meetings, and nursing homes, to name a few. Here are some of the typical questions that have been asked after my presentations. Question: with the price of copper so high, why are the cables still in the ocean? Answer is it would cost too much to haul up the cables, strip them of the many layers around the copper. Question, is there any place the cables can be seen today? Yes, go to the beach at Nauset Light or Coast Guard. A few of the cables can be seen sticking out of the dunes. Here's one of them. Question, why did the first French cable go into Duxbury, Mass? Simple answer, the British had a monopoly on connections to mainland North America. The cable could not go to mainland. Technically, it did not reach land. It reached a cable owned by a U.S. company that ran from shore out beyond the coastal boundary into international water. So the French cable terminated in international water. Question, when the station closed, what happened to the operators? A few of them went to New York City to work. Others stayed on the Cape and became tradesmen and other workers. You can see their names around Orleans because the families stayed here. Question, are any of the operators still alive? Yes, Henry Ozone worked at the station and is still alive at 88 years old as of March 2020. He was a guide at the museum and was very popular. Question, is there anything interesting about the French families coming to Orleans? Answer, the French were all Catholic. The Orleans Catholic Church was started here to serve them. Question, how did Orleans get its name? Orleans was part of Eastham until 1797 when it became large enough to be a separate town. This was soon after the Revolutionary War, and the citizens did not want a British name. The Duc d'Orléans of France had helped the Americans during the war, so the town was named after him. Question, what is the IEEE Milestone Award? The Institute of Electrical and Electronics Engineers is a worldwide professional engineering association. They present a few awards for significant achievements. Winners in the past include NASA, MIT, Western Union, and Thomas Edison. We are very proud to have received this award. Here's a photo of it. If you have any other questions, email them to the museum, and we will try to answer them for you. Thank you.